Okay, for this lesson, we're going to have to open up Desmos, the online calculator. If you go in there and you're not already signed in, you're going to want to do that up here. Sign in through Google and then use your school email and password. Once you've signed in, go ahead and name your graph. It should say untitled graph here. I've named ours combination of functions. That's going to be ultimately today's lesson. So let's go take a look at the warm-up problem. Graph the function f of x equals x cubed minus 1. State the x-intercept and y-intercept and give the domain and range in interval notation given that x such that negative 2 is less than or equal to x is less than or equal to 2. So the domain, because it says that x is between negative 2 and 2, this is the domain, is written in set builder notation. I know it's set builder notation because of these squiggly looking lines right here, which are just a hump, a point, and a hump. And everything contained within those, they're similar to brackets, I guess, or parentheses. Everything contained within is where we're staying in the graph. So first off, if we want to go to interval notation, here's what the domain and range is going to look like. D for domain, R for range. We have a closed dot. We said that was a bracket for interval notation. That would be an arrow with a line underneath it, meaning less than or equal to for set notation. If you have an open circle, it's going to be a parentheses. And again, the arrow, but this time you won't put a line underneath it. Since we have lines underneath both arrows, that means we need brackets for all our values. And for the domain, we're staying between negative 2 and positive 2. Now we've got to go figure out what the range is going to be. These are the inputs right here. So given, sorry for the horrible handwriting, given this function, we want to input all the numbers starting with negative 2 all the way up to positive 2. We want to see what we get out, and that'll be our range. So let's go look at Desmos. What we're going to do is click into the first text box. We're going to type our function f of x is equal to x. I'm going to grab this keyboard down here, click the a raised to the b power, and then I'm going to tell it that power should be 3 minus 1. I'm going to click for a second text box. I'm going to create a table. I'm going to hit the, let's get rid of this. This keeps coming back and bugging us. When I'm in the second text box, I'm going to click the plus sign, go to table. We're going to type in our values. We want negative 2, negative 1, 0, 1, and 2. And then over here, we're going to type f of x. I think maybe what it doesn't like is this x sub 1, because I don't have an x sub 1 there. Let's see if we can get rid of this 1. Call this f sub 1. We'll call this f sub 1. Still got that little gap there. Get rid of that. There we go. So now I have my numbers negative 2, negative 1, 0, 1, and 2. And it automatically gives me all the outputs here. So I've got to make sure everything in this table matches everything in this equation so that it'll give me both of those things. But at any rate, it looks like now our values are negative 9, negative 2, negative 1, 0, and 7. Or in other words, it's going to start at negative 9 and go all the way up to 7. That's going to be continuous. So it's going to hit all the numbers in between, but it gave me the most clean numbers for each of those individual inputs. Going back to negative 9 to 7. So -9 is our lowest value. It has a bracket because of the line underneath the arrows, and that's going to go all the way up to 7. That means at -2, -9, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's going to start right about there. Solid because of the bracket, solid because there's a line underneath the arrow. It's going to cruise on up through. Let's double check. Looks like it goes through -1, 0. I'm sorry, 0, -1. I said that backwards. And then it cruises all the way up to 2, 7, 1, 2, 1, 2, 3, 4, 5, 6, 7, right about there. So not the coolest line. Make sure it stops right at those dots. We're limited. We're not going past those points. And so now it looks like the y-intercept is going to be 0, -1. And the x-intercept, we can go back and look at the graph. Remember, you can touch the points 1, 0. So it should actually go through here. It should curl a little better. 1, 0. That'll be the x-intercept. So we changed it from set builder notation over to interval notation. We've identified the y-intercept, the x-intercept, and we figured out what the line looks like in between the values of -2 and 2 for the domain. All right, let's get into the actual lesson. This is some Algebra 1 reminders, collecting like terms. If I had 12r minus 8 minus 12, one thing algebra teachers like to tell you is that this guy has an r. So maybe you put a triangle around it. This guy, the -8, does not have any letters, no variables. So I'm going to give him a different shape. -12 is just a number without any variables as well. The variables are the letters, so I'm going to put a circle around that. The idea is 12r is the only one of its kind, the only one with a variable, but -8 and -12 are both numbers without variables. We're going to add those together, and that would give us -20. So collecting like terms is just putting together things that look the same. So again, if I were to look at this one, I'll notice this has the letter N. This also has the letter N. I want to combine those two. This is technically 1N. 1N plus 9N is 10 N's altogether. Here's a numerical value without a variable. Here's another one. So those two in the triangles are the same. -10 and -3 is -13. So that would be my answer for this problem if I collected like terms. Let's look at some more. Looking at this problem, I see that I have 12r. Any other r's in here? Yep, there's 3r. 12r and 3r makes 15 r's altogether. And then I'll put a square around. It doesn't matter what shape you use. You don't even have to do the shapes if you don't want. If you have a +5 and a -5, they're actually going to cancel each other out. 5 minus 5 is 0. So the final answer, 15r. Let's see what's under here. We're going to make them a little bit more difficult. So in this problem, notice the new change here is this square. We've got an exponent with a 2. This guy does not have an exponent. Technically, his is 1 when you don't see it there. So those are different. They have to have the same exponents to be able to put them together. You can't just say I see w's and add them. They have to also have the same exponents. So clearing that out, 6w squared is exponent's 2. Does anybody else have an exponent of 2? Yep, this guy does right here. So if I have 6w squareds and 8w squareds, that's a total of 14w squareds. Then this guy is just a w. He's not squared. And this guy is also a w not squared. If you have 11, but you take away 15 w's, It's going to leave you with a negative 4w. So our final answer for this is 14w squared minus 4w. Here's a longer problem, but same idea. You got to look at all these exponents. This guy has a 4. Anybody else have a 4? That's it. 12x to the 4th. This guy is negative 16x cubed. He's got a 3 at the top. Anybody else got a 3? Ooh, there it is. Right there. Keep looking. There could still be another one. I guess not in this case. So negative 16x cubed plus 12x cubed. That leaves you negative 4x cubed. Let's grab a new color. Let's do green. So this guy's gone. I've done him, done him, done him. So now we've got positive 4x squared. The exponent's a little 2. Anybody else got a little 2? How about this one right here? Positive 4, take away 3x squared. I think that's going to be 1 left, 1x squared. Lastly, I've got a negative 6x. Nobody else looks like him. And positive 18. Nobody else looks like him. And now I've done every term. I've put together everything I can. So that would be the final answer. 12x to the 4th minus 4x cubed plus 1x squared minus 6x plus 18. Okay, again, this is your domain, the x side. That is also referred to as your inputs. And then this side is our range, also referred to as the outputs. Given this equation, y equals negative 6x minus 7, we want to plug in negative 8, 2, and 1 and see what would come out. So the idea is, given that x, we're going to replace x. Instead of writing the x right there, I'm going to write a negative 8 minus 7. I'm just sticking negative 8 in the equation. We want to calculate this, see what we get. Negative 6 times negative 8. When two numbers are next to each other, it means multiply. Negative 6 times negative 8 is positive. Two negatives is a positive 48 minus 7. And 48 minus 7 is equal to 41. So the y value would be 41. Let's do it again for 2. The idea is you're going to say y equals negative 6 times 2. You're plugging in the 2 minus 7 is equal to negative 12 minus 7, which is equal to negative 19. So given the input is 2, the output is negative 19. And if we plug a 1 in there, y equals negative 6 times 1. Notice the inputs go in parentheses. Minus 7. That would be negative 6 minus 7, which is equal to negative 13. And we can do that again with this one. We've got a new function, x plus 9. I'll write that down because I'm going to go to a new screen, and the numbers are 1, 8, 7. Sorry, 1, negative 8, 7. If you want to be quicker about this, you can go to Desmos. We'll X out of this. Just like you said f of x, that's the same as saying y. So we can say y equals x plus 9 in text box 2. We can create a table using the plus sign. And we'll get rid of this little x1. We'll type that our values are 1, negative 8, and 7. I'm going to come up here and type a little 1 right there. So that way y1 and y1 match, x and x match. And you'll see it give me my output, 10, 1, and 16. Go back to the problem, 10, 1, 16. So that's a little bit quicker than having to plug it in and calculate yourself. The idea is we just got an input and an output. Here is something similar. So A lot of times we're going to be given more than one function. This function is g of x, this function's f of x, and this one is j. You can't tell. We need to look and see which function they want us to use. First off, they want us to use g. Now, that means we're using this guy. Notice this is g of x and this is g of 10. The idea is they just put a 10 in place of the x. And again, right here, I'll put another 10 in place of the x. Plus 1. It's the same idea as what was up top. So given g of 10, that would equal negative 30 plus 1, which is equal to negative 29. So the answer to this is negative 29. Let's take a look at the next problem. This one says do f of 3. So that means we need to use the f equation, which is x plus 7, but instead of x, we're going to plug a 3 in. Here's what that looks like. F of 3 is equal to 3 plus 7. Well, 3 plus 7 is just 10. So the answer to this is going to be 10. Let's look at one more and then we'll practice this just to make sure you got it down. Looks like this says f of negative 2 again. It's kind of hard to tell, but we'll assume this says f. So again, they want us to use the same equation. F of negative 2 would be negative 2 plus 7. Negative 2 plus 7 is equal to positive 5. So these are just inputs and outputs. Let's go practice.